Hello everyone. Today we'll talk about protocol. What is a protocol? A protocol is a blueprint of methods, properties, operators, and subscripts, and it can be adopted by a class, struct, and enum. Let's look at an example. Here we define a protocol called walkable protocol, and this protocol has one function called walk. And then we have a class dog which adopts the protocol of walkable protocol. And because the dog adopts this protocol, it has to implement the function of walk. If we remove this function, this code won't compile because the dog has broken its promise of implementing that function. So by this, we say the walkable protocol is adopted by dog, or the dog is conforming to the walkable protocol. Not only a class can adopt a protocol, a struct and enum can also adopt a protocol. Here we have an example of struct goose, which adopts the protocol of walkable protocol, and enum fox also conforms to the protocol. And then here we create a x, which is a goose, and we can upcast x from a goose to a walkable protocol. So this means a protocol can be used as a type. So w is a variable of type walkable protocol, and w can also be downcast back to a goose. So this is a last type of casting that we'll talk about. As a summary, there are 4 types of casting that we have talked about. The first one is a casting between superclass and subclasses. This can only happen to classes. Second one is cast to and from any object, and this can also only happen to a class. Cast to and from any, this can happen to any kind of data, whether it's class, struct, enum, or closure. The last one is what we talked about today, cast to and from a protocol, and later on we'll also talk about casting between protocols. And this kind of casting can happen to class, struct, and enum. In this example, we have seen a protocol that defines a method. Things are very similar for a protocol of operators and protocol of subscripts. But for the protocol of properties, things are a little different. Let's look at the example of protocol of properties. Here we have a protocol called named protocol, and this protocol defines a variable called name. And this name has both a getter and a setter, which means this property needs to be both readable and writable. And then we have a class cat that conforms to both the walkable protocol and named protocol. This means that the cat must implement the function of walk, and it must has a property called name, and this name needs to be both readable and writable. So if we change this name from a var to a let, then this protocol is broken and the code will not compile. Similarly, we have an aged protocol. An aged protocol defines a property called age, and this age only has a getter. This means that in order to conform to the aged protocol, you must have a property called age that is readable. Whether it is writable, I don't care. It's none of my business. So if we have a class A that is conforming to aged protocol, it must have a property of age. And even though the age is a var, it is still conforming to the aged protocol. And if we change it to let, it's still conforming to the aged protocol. And the property doesn't even have to be a stored property. It can be a computed property. Here we have an example class B, which conforms to the aged protocol, and it only has a computed property of age. This is perfectly fine. Now let's talk about the protocol of mutating method. If you recall, a mutating method is a method of struct or enum that change itself state. So a class doesn't have a mutating method, only struct and enum have mutating method. And here we have a protocol toggleable, which defines a mutating function called toggle. And then we have a struct C, which conforms to the protocol of toggleable. Then struct C must define a mutating function toggle, and this function changes itself properties. And same thing for enum. But what about class? If we have a class D, the class can also conform to the toggleable protocol. But in the case of class, the keyword mutating doesn't really make sense. So for class, we only need to define a function called toggle. And that means the class is conforming to the protocol. As we talked about previously, a protocol can be used as a type. So here we create an array of A, and A is an array of walkable protocol, which means the array can hold any object that conforms to the protocol of walkable protocol. So we can append a dog into the array of A, we can append a cat into the array of A, because both dog and cat conforms to the walkable protocol. And if we have a function foo which takes a walkable protocol as a parameter, we can call the function foo with a dog or a cat. Protocols are like classes. One protocol can be derived from another. For example, here we have a runnable protocol which is derived from walkable protocol. This means that all the things defined inside the walkable protocol, whether it's properties or methods or subscripts, are inherited by the runnable protocol. And in addition to that, runnable protocol can define new things for itself. In this example, it has defined a new method called run. And if we have a class wolf that is conforming to runnable protocol, the class wolf must implement the function of walk, which comes from the walkable protocol, and the function run, which comes from the runnable protocol. Multiple protocols can be composed together. For example, here we have a variable y, and y must be a data that conforms to both walkable protocol and the named protocol. So by using the protocol syntax, we can compose multiple protocols into one protocol. And by this kind of composition, you can create even more complicated protocol. For example, here we have a habitable protocol, and this protocol defines a property called creatures, and creatures is an array of data that conforms to both walkable protocol and the named protocol. You might want to pause the video and think about the relationship. Protocol also supports conformance check and casting. For example, here we have a protocol edible, and we have a class apple which conforms to the protocol of edible. And then we create a1 which is an apple, and a1 can be casted from an apple into an edible and assigned to the variable of e. This is called upcasting, and for upcasting you don't necessarily have the as statement. You can just assign a1 to an edible. And since e is an edible, we can check whether e is really an apple or not by doing if e is apple and we do something about it. This is called runtime type identification. And we can also cast e back to apple. This is downcasting, and downcasting must use the as statement. But be careful though, if e is apple, this is okay. But if e is really not an apple, this will cause a runtime error and your code will crash. A safer way to do this is using e as apple. This statement will return an optional, and if e is really not an apple, it will return a nil instead of a runtime error. You might have noticed this at Objective-C sign. This means that the protocol is exposed to Objective-C code, which also means that this protocol can only be used by a class. not by a structure or a enum. A protocol can also have optional requirements. For example, here we have a protocol called Synnable, and it has a property called color, and it has a method called greet. But the greet method is an optional requirement of this protocol, which means I don't have to implement this method in order to conform to this protocol. So here we have a class kite, which is conforming to the Synnable protocol, but I don't have to implement the greet function. I have to have the color property, but I don't have to have the greet function. But the problem is, if I create a k which is a keyable, I don't know if k has the implementation of the greet function or not. So if I do k.greet and k doesn't have the greet method, then this will cause a runtime error. A safer way to do this is using k.greet question mark. Now, if the greet method is not implemented, this will simply return nil. Thank you for watching. Feel free to download the notes from my website and practice with it. See you next time.